So I guess the question is, using our binomial calculator, if the chance of an event occurring is 30.4%, you have 99 trials and you get 30, what's the chance of that happening? Sorry, 60.8. 60 point, I guess we'll be exact, 60.79. I got the feeling that the chance is really low. It's non-existent. So is there any reason why this could be why these, because like if this was the pi over 2 model, it would make more sense. The 3 pi squared model. I guess when you wheel somebody into oblivion like they did over in Georgia and Pennsylvania, you really do get this result. Because the using this adjusted formula, 6 over pi squared instead of 3 over pi squared, it actually made what happened in Georgia and Pennsylvania a million gajillion times worse. The only thing it fixed was Michigan. It actually absolved Michigan when it comes to a GCD test. So Michigan would be acquitted on a GCD test. But Pennsylvania and Georgia would be even worse. They only had 11% of their ratios being irreducible on average. I think it was 9 and the other one was 11. This is insane. It's actually insane. GCD analysis. So let's pull this over. And we're just going to look at these GCDs. Only the GCDs. And I have to isolate these again. Pretty sure. Well, in this case, they're already isolated. Because I already have the count running down. So I just have to know when the GCD changes. So do isolate, descending, GCD, ascending. Now we get here. Anything where there's only one is okay. Because it's allowed to be something. That's the idea. I would argue against that, though, for the case of 350. So who actually has a GCD of 350? Just out of curiosity. Wow. Jesus. And in both these cases, it was a split tie with these really high GCDs. That's actually really weird. That's like beyond weird. That's Holly weird. I mean, the only way this could be is if they like literally prepaid everybody and told them like who they're gonna vote for. Or they had a handful of people that they were ready to pay off to make it a tie at this caucus. Because, like, that makes no sense. I'm sorry. That's just weird. But anyway, barring that, so you know what? Some of these G's, they just don't make sense. Like, this whole thing doesn't make sense at this point. So, like, let's say hypothetically we had 30 GCD out to 34. Then, let me close all these extra tabs real quick. Kilowatt, I will send in your request. Just give me like 2 more seconds. I forgot what I was doing because the sync is on. Let me see. I actually completely forgot what I was about to do, but I know it was important. Oh, okay. Wolfram. So what is the sum 1 over n squared to 33, and then this will be uh, 6 over pi squared. So that's already up to 98% of all possible GCDs. So I feel I could say with pretty good confidence that this is exactly what it's supposed to be. Like maybe this would be like 59% instead of 60. Like it's not going to change that much. So with that in mind, let's add these up real quick. $100. Let's add this up. $95. It's because we're getting a lot more out of it's so who's pumping in all the extra values? This one is. And this one. The ones I have flagged are still flagged. Like they're the weirdest by far. So let's do this. And then AT will be our x-axis. Okay. Data series. Well, maybe because since the red one is just a line, we can go with this. This will be AT. I want to make this bigger. So this is the most important by far. So let's do that first. And then what we'll do is let's call it what it is, the bullshit meter. I like the bullshit meter. The bullshit meter is my favorite meter. Because people don't understand like what these divergences mean until they see the bullshit meter. So this is equal to, okay, we're going to write it this way. If come on now. If the count equals 1, then 1. We have to go a little further than that, so we'll do an AND. So if the count is equal to 1 and AV2 and the GCD is greater than, I guess we can go with 10, then the bullshit meter is 1 because it's allowed to be something. Otherwise, the value is equal to actual over expected. Oh, hold on, we gotta do one more thing. Then, if is greater than this, then this, an AX2 over AW2, otherwise this version. Okay. That's how it works. I love the bullshit meter. I'm always going to keep it the bullshit meter. That's like literally what it is. And let's get this one. Insert chart. And this one is still AT. That bullshit meter went up fast, didn't it? Wow, that thing spikes so hard. That's nuts. Who is this? They got the 120. That's nutso. That thing's fucking up the rest of the graph though. You can't really see everything else because of that. Like, this is what you want to see. We'll just drag it to the bottom. Oh shit, that is funny. That is funny. So we'll put it over here so it's not blocking. I do have to go to the dentist at 2 o'clock, so I have to close the stream soon. I have to shave too before I go. I actually think this is the best way to show the graph. There's so much bullshit that I had to we had to make the graph almost as tall as the spreadsheet for people to see the whole thing the way it's supposed to be shown. It's actually that bad. The bullshit meter. Ratio of expected of actual to expected. If GCD is greater than 10 and only occurs once, value equals 1. If expected is greater than actual, then ratio is inverted as reciprocal. This would be the GCD. This would be the bullshit level. Alright, very good. Alright. And we're not talking probability, we're talking densities. That's why people need to see the bullshit meter, because we're talking a problem of density. We're not talking a problem of probability. Even though it's like technically the same thing, we're talking about we're using the density as a probability. We're talking about something that's supposed to have a very, very strict conformance. It's a question of density. You know what this would be like? It'd be like if somebody shined a flashlight through this triangle and they never hit an orange square. This is what we're talking about. You can't say, oh, well, approximately 30% of them are white squares. So there's actually a chance that if you shine a flashlight through the triangle, you might actually get to the other side without hitting an orange square. No, bro. It's just this fucking density. You're never gonna shine a fucking laser beam through this triangle without hitting an orange square. But apparently the Democrats have found a way to do that. I'll be right back. Jose Martinez, I would like to entertain it as quantum tunneling, but if I actually said that, then the Democrats would say, oh, this is a perfectly legitimate result. It's analogous to quantum tunneling. Like, that is what they would do. It's so fucking crazy. So now there's, technically, if you lean against the wall, there's a chance that your body will fall through it. If the atoms all line up correctly. And that's what really happened in 2020. Yeah, that's actually true. If the atoms lined up perfectly in such a way in a crystalline formation, and your body also assumed the same crystalline formation, and you leaned into the wall, you would fall through a wall. It actually is possible. It just never will actually happen. Martinez, I didn't do any mind tricks. I literally made a manual error like all fools, and I didn't divide by 2 to get the area of a triangle. That's all. I'll be right back. take a look. I have a few more minutes before I have to get ready for the dentist. Let's take a look. I think Trump is going to speak today, if I'm not mistaken. Hopefully that event is still on. I heard Michael Pence is going to be there from chat earlier. So that's usually not a good thing. That doesn't bode well. I don't know how Pence would manage to walk through the crowd. He would need, I think there's enough unruly, pissed off Americans that could potentially hurt him if he's not protected. So he would need Secret Service protection to walk through a crowd right now. That's what I think. So I can't see why Pence would want to show up. He would only get booed. So we had a pass, I think it was 1901. Adjudicated pass. So I guess we do. We're going to go balance this with, we're going to see if we can balance here. Like, we'll see. We'll see what happens. Wheel balancing. Put it here. This is what I pretty much have down to a science. I just don't know if we apply it on the whole set or just the things that I said were transfers. I guess we'll find out now whether or not I can balance it. Alright, so our operator is 1901. Quite sure. What we're going to do now sort this. Least the greatest by the SG. This will be spoke number. This is floor. D2 over G2 times money sign P money sign 3. Okay. Actually, it's ceiling. Because if we're claiming this is the solution to an inverse floor function, then we have to ceiling it. When you do things this way, you get a much better idea of how many transfers really occurred. Because now we're on the spokes, we're no longer dealing with the ratio itself. So this is the true amount of transfers. It's anything that's on the same spoke. So we'll do if this equals this, and this, otherwise 1 plus this. Okay. But the problem is when you try to do this analysis before you have a wheel number, you don't really know how many transfers, you don't truly know the amount of transfers until you have it like this. At the same time, you could very easily flag false positives if you just ran a wheel number on an entire data set. Not everything gets seized. So we got to make sure we're not doing that, but we'll know very quickly when we try to balance. I have a feeling this one will balance, because I think every single result in here is funny, or just about. So this is equal to if equals this, then one plus this, otherwise 1. Spoke weight. Do have to enter the first one manually. It's 200. And if spoke equals, we can use u here. If u is equal to this, then this plus this, otherwise just this. Should be that simple. So at least 19 transfers occurred. It's the minimum. After that, if we can't balance, then we'll just look at the ones where we have repeated spoke numbers. It's really not that hard to do. Okay. What we need to do now is sort by spoke number and then spoke V descending. So all the weights come to the top. Detection. If spoke is changing, then we want true, otherwise false. I'm going to bring detect descending and then spoke number ascending. There are our weights. Oh, I was gonna say, Jesus Christ. Same number. See everything. And I need now is burn ideal. That's simply equal to W2 over 1901 times Z2. Okay. Why do I feel like this is actually about to be perfectly balanced? I'm actually feeling in my gut this is going to be perfectly balanced. So I got 69,518. Okay. Now I guess the question is, what happens when I do a uniform weight? Random number generator. We'll do from 200 to 2000. All right, 1406. It should be interesting. It should be really interesting. So here's the question. What is AH 82 over AH AG 82? And now may I ask, what is AA 82 over Z 82? It's actually too much. It's not balanced. It's too big. 2% is too much for me to claim balance. That's too much for me to stomach. So guys, anyway, so when I get perfectly balanced wheels within negative 0.00004% in Georgia, just know that that means I proved something. So as you can see, it just doesn't happen to always work out that way. I'm off by 2%, which is huge. Alright, so, by the way, that's the video that they deleted. The only video that they actually deleted and struck is the one where I balanced it to fucking 0. So, let's take a look here. So, obviously we have to look at only transfers or something. I'll have to figure this out after I come back from the dentist. Because obviously something happened in this primary. That's obvious from all the other data we have and models. We definitely don't have anywhere near a balanced wheel. It's not even close. So if these were all the transfers, like let's say like every single one was a predetermined aggregate for Bernie, then that means that the wheel actually gave him more than he was supposed to get, which that's not how the wheel works. It's supposed to be the other way around. This should always be less than this. So we have to figure out what actually happened, and we'll look at the transfers when I get back. The ones where we have repeated spoke numbers. I'm going to close the stream. I'll be back after I'm back from the dentist. So, like I said, for people who are in chat, my fellow mathematicians that are in the channel. As you can see, a wheel doesn't balance by accident. It's not like there's some weird law of averages where things converge to just make it that way. So when I have negative 0.004% as my balancing in Georgia, basically 0%, it means I proved Georgia. So I'll be restarting when I come back from the dentist. Alright, I just want to make sure, like, somebody said good luck. I just want to make sure, like, my stream was alive. Like, I don't know when they're gonna... I'm, like, paranoid about them striking me at any moment.